Hey there, Stephen Barter here. How are you doing on this great day? Me, well, I'm feeling somewhat anxious to be honest, and I'm also very curious because today we're going to pull together lessons 1 through to 4 from the Mold is a Heat Exchanger series into a singular mindset. Very importantly, if you haven't watched the previous 4 videos, then go back and watch them. Apply what you have learned. Individually, each of these modules will create a massive difference. But pull them all together and use them as one will create a recipe that will rock your world. The most important thing you can do is to look at your business differently and make incremental changes to create that elusive stability. Apply lessons 1 through to 4 and they'll do exactly that for you. So I'm anxious, I'm also curious, and I can't wait to show you more today on ProMold Lesson 5 as we're pulling it all together. So here we are, pulling it all together in Module 5. So I just want to do a quick revision and go through the last 4 videos. So from Lesson 1 we talked about the water pressure, measuring the pressure differentials in the mould to prove the flow. Measuring the input and output pressures, you need to have a differential of 1.5 to 2.5 bar. If you don't have this, then you will be out of control. Water temperature is also important, but it's a lower priority. So the key here is to make sure the water flow through the moulds is the first priority. What I like to do is choose a temperature that will enable you to keep the same water temperature all year round regardless of the weathering conditions, and that will enable you to keep a bit more stability in your process. Lesson 2, we talked about the extruder temperatures and how they might mislead you. Always independently verify that the actual Paris melt temperature is and that the machine is controlling the temperature correctly. Fix any variations straight away. Do not persist with them. Then in Lesson 3, we talked up the blow air pressure. How important it is to make sure that we are getting full pressure. How quickly it gets to full pressure and how quickly the air is deflating out of the moulding after. Then we go into Lesson 4, which is probably the most complex lesson so far. It's also my favourite. Bottle mapping is so crucial to optimizing the bottle molding conditions. And then how quickly do I identify problems as they arise. When the bottle is not performing, then the bottle mapping will tell you exactly where the problem is. Okay, so pulling it all together requires recipe recording and of course monitoring. On this slide you can see I've collated some data and as a representation of what you must add to your product data or recipe. When you first start to capture this information, make sure you take the time to do it on every product. Go through the same data collection exercise. Gathering this intelligence will tell you straight away if you have any issues that must be dealt with. For example, 2 different molds may have very different pressure readings. If you find any irregular parameters, then make the necessary corrections before you record any of this data on any setup sheet documentation as a permanent reference. These measures are designed to make your process stable, so make sure any issues are fixed straight away. The timing of when you're gathering your information is also really important. My preferred time for existing products is to complete the checks at the startup of a mold change, and of course as soon as there is a hint of any sort of quality concern. Doing the checks at startup means that you're setting yourself up for success in the production run to follow. Very important. Keeping historical information documented, typically on a setup sheet, will show you how much control you have and whether you have progressive errors that are trying to steal their way into the process. So make sure you keep the historical values for future reference. So now this point is really important. New tooling process inputs are absolutely critical. They are the main component of your recipe. So if you don't know what they are, how can you be sure you are making the bottle to stable conditions? What if you were to modify the mold based upon bottle data that you collected using a process that was out of control? You could potentially ruin a brand new production tool and send it back for remodels and reworks time and time again until you get it right. Always make sure you have the process in control, and the only way you can do this is to measure the components from my lessons 1, 2, 3, and of course lesson 4 will help you optimize the conditions. So I just want to share an experience with you I had a few years ago, and this is actually a true story. I had the same mould and the same bottle weight, with bottle mapping completed and matched for two very different sites. When I asked the previous moulder what their setup conditions were for the water, air and melt temperature, the response was they just didn't know. Their process recipe was actually unknown, so when we installed the same mould into our machine, the 500ml bottle, which is only a small bottle, was 2.5mm taller. The only condition we could match was the wall section and the weight, and we had proven this by using my bottle mapping process. We were able to do that with the older bottle and the new bottle. They were exactly the same. So the rest was from poor water, air, pressure. Yeah, and who knows what the melt temperature was. The previous moulder themselves, they didn't know. The benefit I had is that I knew exactly what the recipe I was moulding to, so I could confidently modify the mould to suit the dimensions the customer was used to filling and their filling machines were used to running. So what you must do in each and every component from lesson 1 through to 4 to your existing setup documentation is to record the information for each product, refer back over time, and check for any trends. That's really important as well. Different moulds have different water pressure readings. Regardless of whether they are higher or lower, the same rule still applies to the differential in the water that you learnt in lesson 1. Extruded temperature controls, well, they do break down, and without you knowing it many times. So always check the melt temperature. Do this every time. And really importantly, be brave enough not to process around these inputs. If they are not correct, then you need to make them right. So as soon as you identify there's an issue, you've got to get straight onto it. This will reduce risk and also demonstrate how serious you are about process control. So next to this video on the main website, there is the Excel file that I've used in this video. So just download it, complete the information on just one of your products and email it to me at results@protechnical.net for some quick feedback. Maybe even include some of your plans to fix the data that's affecting the result. So that's it this week for lesson 5. Next, in lesson 6, we'll cover variables and non-variables in the extrusion blow molding process. That's another biggie. And don't forget about my rules to live by. Work with facts, work with data and facts. Question anything you're not sure of. Pressure is a result of resistance to flow. Know what your inputs are to get a predictable result. Know and measure the variables, and never trust a computer. So have a great day, have a lot of fun checking your results, but most importantly, until then, have fun blowing a bottle.